Everyone, and welcome back. It's Kira Garfolo with Greenville Tech's Math 155. Today we're going to talk about section 1.5, which is an introduction to percents. So backing up to the very basics, some of this is probably a review, but what are percents? What do I mean when I say percent? All of us have heard the term percent, but we may not have thought what it means mathematically. Percent literally means per 100, okay? So when you see the percent sign, I want you to think 1 over 100, okay? Because you're going to end up multiplying many times by this 1 over 100 piece, okay? So for example, you have 80%, and you know that you can find the decimal version of that by taking the 80, then this is the percent piece, okay? So 80 times 1 over 100, and you could type that straight into your calculator. You're going to be able to get that equals 0.8. I've written it out by hand here, but obviously if you're using a calculator, you'd skip some of these steps. So 80% means 80 per 100, which is 0.8 in decimal form. Your calculator will also convert directly to percent. So if you typed 0.8 and you press second and the percent sign, which is really the open parenthesis key, you will get it to go to 0.8. And it will take it to 80%. Now, if we want to go from a percent to a decimal, then there's several options, okay? Let's talk about 30%. So like I was just saying, our calculator will do it for us directly. We can type 30 and then press the percent button. Or again, this is going to be the second button. And then you're going to press the open parenthesis button, okay? Because there's going to be a little percent above it. Mathematically, you can also replace percent with that 1 over 100. So like we saw earlier, 30 times 1 over 100 is going to be 0.3. And also when you're talking about percents, dividing by 100 is the same as moving the decimal left 2 places, and then you drop the percent sign. So we start with 30. Remember, that would be 30 with the decimal there. And we're going to go 1, 2 to the left, okay? So that's going to give us 0.30 or 0.3. Many ways here for a lot of this section. Now, if you're given a decimal or you're given a fraction, you can easily convert that to percent as well. Now, if we're wanting to go into percent, we need to move the decimal place to the right. So we're going to go the other way. When we have 0.65, we're going to move that decimal 2 places over here to get 65%. We can do the same exact thing with fractions. We just need to put the fraction into the decimal form first. So into your calculator, type 3 over 8. And remember, you can press that little button that looks like this kind of, these little things covered in. That's going to switch between fraction and decimal. So if you type 3/8 and it gives you 3/8, just press that button and press, it'll give you the decimal form. Now you can multiply it by 100, or you can move the decimal 2 places and get that 37.5%, okay? So this is the same as times 100, okay? So let's practice. Again, I'll say this in every slide and you'll get tired of hearing me, but definitely take a moment and pause these. Make sure that you can work them out from scratch because they're very much like something that you're going to see later. If we want to change 75 from a percent into a fraction, remember we're going from 75%. So we're going to have 75 per 100, right? So if we're doing 75 per 100, you can say, okay, I know I have 75 times 1 over 100. That's going to be that percent piece. And if we enter that into our calculator, we're going to get 0.75, okay? You could also have just moved your decimal 2 to the left. Whatever makes the most sense to you, they're equivalent. What about if we want to put 0.05% into a fraction, okay? I guess I should read above. We wanted a fraction here. Reading is fundamental. Here, you're going to get 75 over 100. which is 0.75, which is also, if you simplify that fraction, 3 out of 4. I don't expect you to simplify fractions unless I tell you to simplify them. So if you had seen this one on a test, the answer 75 over 100 would be okay for credit, okay, unless I told you to simplify. Now, if we're going to do the same thing, 0.05% into a fraction, remember you're dealing 0.05 and that 1 over 100%. That's just going to be 0.05 over 100. Okay, now you can leave it like that. If you wanted to simplify it, you could get rid of this. That's actually going to be 5 over 10,000. Whatever you prefer. We've got to multiply, to get rid of this, we've got to multiply by 100. So we multiply both sides by 100, or top and bottom by 100, excuse me. Either of those would be fine. What about if we want 1/4 from a fraction to a percent? Well, remember first that we want to go fraction to decimal to percent, okay? So 1/4 in our calculator is going to be 0.25. Making that into a percent is going to be 25%. Okay? So if you're going from a percent to a fraction, put a note over here. So percent to fraction, you're going to put the percent over 100. So 3% is going to be 3 over 100, etc. Okay, lots more practice. Okay, what about 30% into a common fraction? Don't get bogged down by this word here, common. Just kind of ignore it. You're just putting 30% into a fraction. We just saw, okay, well, that means 30 over 100. That's an okay answer, okay? You can leave it just like that. Or if you want to simplify it, it's going to be 3 over 10. What about 5.7 into a percent? Well, remember when we're doing percentages, we want to go to the right. So 5.7, 2 over there is going to be 570%. Okay. Remember, number 2% multiply by 100. Going the other way, we divide by 100. Okay, what about 0.003 into a percent? Well, same thing. We want to have 0.003 times 100, or we can just move that decimal 2 over. Mathematically, we're doing the same thing. Both ways are going to give us 0.3%. Make sure that you can replicate these on your own. These are easy test questions, and I hate to have to mark them wrong. Okay. What about changing 0.08% into a decimal? Now notice we're going the other way. If we're going into a decimal, remember that we want to go to the left. Or you can put 0.08 over 100. Either way, that's going to give us 0.008. Above 1 here and here. Our decimal will be there. We'll have 3 zeros, 8. You can put this in your calculator also, and it'll spit that out. What if we want to put 36 over 51 into a percent? Well, again, put this into decimal and then go to percent. We can find in our calculator pretty easily that 36 over 51 is roughly 0.70588. And so if we want to put that into a percent, we'll move it 2, and we'll end up with 70.6%, roughly. Now, I will tell you what to round to usually, and if I don't, then it's up to you. If you had done 70.588%, that would be correct. Use common sense here. Usually, You're going to want to at least round to 1 or 2 decimal places. Okay, now we can think more critically, but apply the exact same reasoning here. If I double a number, then what percent do I need to multiply by? Well, go back to what we just learned. If we're doubling, we are multiplying it by 2. What percent is 2? Well, 2 is 200%. So you're actually going to multiply it by 200%. Okay? So 200% is the answer here. What if I take half of a number? What percent do I multiply by? Well, half, remember, is 1/2 of the fraction, because the decimal is 0.5. If I convert that decimal into a percent, then I'm going to go 2 over here, which is going to give me 50%. Okay, so I'm multiplying by 50% if I'm taking half of it. Lastly, give this one a try. If I multiply a number by 3/4, what percent did I multiply by? Well, again, first step is to put this into a decimal. We know that 3/4 is 0.75. What percent is 0.75? Well, move that decimal over there and you'll get 75%. Make sure that you give that a try and you can get the same types of answers. Now we can work a little bit backwards too. If we want to find some percent of a number, okay? So we want to work in real world applications here. The best way that I like to think about this is when you see of, you are going to think of multiply, okay? So if you're finding 50% of 100, you're going to multiply 50% times 100, okay? Another example is if you're taking 150% of 500. Take your 150 and your percent, the 150 times 1 over 100, and then multiply that. This is your of 500. And you can put this directly in your calculator like this, or you can simplify, or some of you will look at 150% and disable, that's 1.5, and that's fine if you can make that jump. But if not, put this directly in your calculator. 150% of something is 500. Now this makes sense. For everything you do in this class, I want you to pause for a second and make sure that things make sense, okay? Remember that anything over 100% is going to be bigger than the original, okay? Anything over 100% is bigger than the original. So you wouldn't want to pay 150% for something, right? You'd prefer just to pay 100%, whatever it was to start with. Now, for these problems, there are very many ways to get to the same answer, okay? So if you don't do it the way that I immediately jump to, my brain works differently than yours. Your neighbor's brain works differently from yours, okay? That is totally fine. As long as you're mathematically sound in your approach and you're getting the right answer, not out of luck, then that's great. I've presented several different ways to get these answers already, and you're free to use whichever one makes the most sense to you. Now we can also work with that application a little bit the other way. What percent of some number is another number? Now remember that of is going to be your multiply, but now think of is as equals, okay? So for example, what percent of 80 is 16? Well, of 80, we're multiplying 80 by something. So we're saying 80 times something. And is 16. So that's going to be our equals 16. We need to solve here for that question mark. Okay. If we want to use our x as our variable, then we know that 80 times x is 16, which is what I drew right here. And now we just solve for x. Divide both sides by 80, and you'll get 0.2. And remember, we want it as a percent, so we're going to have it as 20%. Set it up as an equation and solve for your missing value. Now remember, you can always check your work here. If I say that 16 is 20% of 80, then I should be able to say, okay, well, 80 times 0.20, or 80 times 20 over 100, both of those should equal 16 in the calculator, and they do. So these are nice that you have a way to check your work. Okay, let's take some practice here as well. Again, pause as you need. We want to find 25% of 80. So that of tells us that we're multiplying, okay? So we're going to say 25%, 25 times 1 over 100 times 180, okay? You could also here say 0.25 directly if you moved that decimal times 180. These are doing the exact same thing, okay? So however you want, you can just put this directly into your calculator or this directly into your calculator. And when we do that, we are going to get 45. Now remember, you can always check your answer. 45 out of 180 should be 0.25, and it is. Okay. What if we want to find 0.25% of 50? Well, this of means multiply. So we're going to have 0.25%, so 1 out of 100 times that 50. And this is going to give us 0.125. Now that's a small number, but that's okay because 0.25% is very small. If you're dealing with very small percents, really remember that that's really 0.0025 as a number. And so you're expecting a small answer. So 0.125 is our answer here. Again, if you had taken a slightly different approach, that's totally fine. Maybe you had done 0.25 and done the thing. So you have 0.0025 times 50. It's all going to give you the same answer. What if we want 2/3% of 50,000? Now these numbers are getting weird and still this is a very small percent, but that's okay. We take the same exact reasoning. We say, okay, well, we want 2/3 and we want percent. So we want times 1 out of 100, and then of means we multiply 50,000. And if we plug this into our calculator just as it is, then we should get somewhere around 33 or 333.33, so on. So we could round it to that. Now, if you had done this part right here first, that's going to be 0.0067 roughly, and that's 6 repeating. So again, many ways to get to this same answer. 333 is 2/3% of 50,000. What if we want 200% of 125? Well, now we say, okay, we want 200 times that 1 over 100, because that's that percent, and then of 125. And if we multiply that there, we're going to get 250. Now, again, does this make sense? Well, 200% is greater than 100%, right? In fact, it's double. So if we are doubling here, it would make sense. Sure, 125 doubled is in fact 250. And we would expect, even just at a glance, that we want more than 125 because we're dealing with over 100%. Okay, now let's talk about some applications here, okay? Same math applies. I know many of my students get really worked up when they see word problems, but remember, it's just the math that you've already learned. You just need to take a breath, write down what you know, and work from there. Mark's weight is 70% of Rob's. If Mark weighs 189 pounds, then how much does Rob weigh? Well, we know that Mark's weight is 70%, so it's going to equal 70% of Rob's, okay? So of some number, X. We're going to be dealing with times here. If Mark weighs 189 pounds, then how much does Rob weigh? Well, we know then that 189 equals 70%, so 0.70, which is that 70 times 1 over 100, times Rob's weight. Let's let that be X, okay? X is what we're looking for here. If we divide both sides by 0.70, we get 189 over 0.70. And in our calculator, we can see that that's 270 equals X. So Rob has to weigh 270 pounds. Okay, and that makes sense. Go back and think about it. Mark weighs 70% of Rob's weight. So Mark weighs less than Rob. We're saying Mark's 189 and Rob's 270. So that's at least practical. We at least got them in the right way. Now, you get 172 questions correct on a test that consists of 200 questions. What is your percent grade on the test? Well, this one is very simple, and I like to ask these on a test. Find the decimal, the proportion that you got right. You got 172 out of the 200 correct, okay? This is going to be 0.86. That's not your final answer. That's the decimal version. This becomes 86%. Now, if you think about that, again, practically, you got 172 out of 200. Yeah, you did pretty well. You got an 86%. Okay? Now, let's say that you own a small company. Your advertising expense is $5,300 and your total expense is $93,800. What percentage is the advertising expense out of your total expense? Now, this was a lot of words for something pretty simple. Your advertising out of your total. $5,300 of the dollars that you spent out of those total $93,800. Put this into decimal form and get 0.0565. We're not done. That's just the decimal. We need the percent. So this is going to be 5.65%. So 5.65% of your money was spent on advertising. Let's get even more practice. 60% of what number is 250? We're looking for this number, so we'll let that be X. Of means multiply. Is means equals. 60% is going to be 60 times 1 over 100. Or you can just think about it as 0.60. Okay? Whichever way it makes sense to think about that. So we know that 0.60 times some number equals 250. If we divide each side by 0.60, we're going to get X equals 250 divided by 0.60, which is going to give us 416.7 rounded to 1 decimal place. Now, does that make sense? 250 being 60% of this number? Yeah, that makes sense because it's over half, right? Okay, well, what's over half of this number? Yeah, 250 makes sense. Same idea. 5 is 15% of what number? Well, we need to think about this same way. What number is X? 5 is means 5 equals, and it's going to be 15%, so 15 times 1 over 100 of some number, okay? So we're going to end up with 5 equals 0.15x, which we divide both sides by 0.15, so 5 divided 0.15 equals x. If we put that into our calculator, we are going to get 33.3 rounded. And that makes sense. 15% of 33.3. Yeah, that would make sense that 5 would be there. That's a reasonable answer. Okay. Now, let's talk about how we can increase or decrease by a percent. Decreasing, a lot of us are used to thinking about if we're thinking about sales when we go to the store. Increasing, if we get a raise, they'll say, hey, your pay is going up by 5%. What does that actually mean mathematically? Well, the easiest way that I have found to do it is to increase a quantity by a percent. You're going to multiply it by 1 plus that percent in decimal form, okay? So if you're increasing by 30%, remember 30% is 0.30, you're going to multiply by 1 plus 0.30, which is 1.3. Same idea works if you're decreasing. You're still going to be dealing with that decimal, but now you're doing 1 minus, okay, because you're decreasing. If you're decreasing by 40, you're going to do 1 minus 0.4. You're going to multiply it by 0.6. So if you're increasing it, you'll multiply it by more than 1. If you're decreasing it, you're going to multiply by less than 1, and that makes sense. Let's think about an example. If it costs $205 to buy a coat, but the sales tax is 8%, then what is the total cost of the coat? Well, another way to say this is you need to increase the price by that 8%. 8% is going to be 0.08 as a decimal, okay? So we need to multiply 205 times 1 plus 0.08, which is going to be 205 times 1.08. Now you could enter all this directly in your calculator and be good to go. This is going to give you 221.40. Okay. So you're going to get $221.40 as your final bill. Even though it was only $205 on the tag, you had to pay that 8% sales tax. Now it's important to note that simultaneous percent changes and back-to-back percent changes are not identical mathematically, okay? So if you do percent changes simultaneously, it's not the same as doing them back-to-back that would add up to the same number. That sounds complex, but let's look at an example to make that make sense. So let's say that you make $30,000 a year, and they say, surprise, you get a 30% raise. How much is your salary going to be now? Well, you're taking that initial $30,000 and you're multiplying it times 1 plus, because it's increasing, the decimal version of 30%. We plug this into our calculator, we see $39,000. So your 30% raise gives you $39,000 now. Now, on the other hand, if I say, hey, you're getting a 20% raise, and then you're going to get a 10% raise the next week. Okay, so we're still getting 20% and 10%, and those technically you may in your head say, well, that adds to 30%. It should be the same, but it's not the same. If we do them consecutively, we say, okay, well, we started here, then we went here, then we went here. And you could break this down into steps too. If you did 30,000 times 1 plus that 20% and got this, then you multiplied that times 1 plus 0.1, you'd get the same thing, okay? If we plug all of these into our calculator, we get that we now have 39,600. Even though they both added up to be 30, simultaneously it was only 39,000, but 20 and then 10 is actually more at 39,600. Why does this make sense? Well, think carefully. 20% raise gave you an increase. Now when you increase that by 10%, you're increasing a bigger number by 10%. You're not just increasing 30,000 by 10%. So that's why. Now let's look at another couple of examples. Let's say that we want to reduce 600 by 40%, then increase it by 20%, then decrease that by 10%. Okay. Now you could do this in a series of steps. I always encourage you to if that's what makes the most sense, but it also makes more room for error, right? So when we're doing these back-to-back-to-back things, we can do it all in one calculation, okay? We're going to start with that 600, and we're reducing it, so we're decreasing it, and 40% is going to be 0.40, okay? 20% is 0.20, and 10% is 0.10, right? We're going to start with our 600, and we're going to multiply it by 1 minus 0.40 for that first decrease. We're going to increase that number by 20%, so we're going to multiply that number times 1 plus 0.20. Then we're going to decrease it again, so multiply it by 1 minus 0.10. And we can do these all in our calculator at once. Just remember to use parentheses, or it'll give you a very wrong answer. So our final answer is going to be 388.8. Now, if you had done this piece first and then done this piece and then done this piece, that would be fine. You would get the same answer. But again, it always saves time just to do them all in one step. Now let's think critically again. Let's say that your boss offers you a 10% raise and then a 10% cut, or you can take the 10% cut now and then a 10% raise. Which one's going to be better? Well, let's say that you make $25,000. Okay, with these, I always like to say, okay, well, instead of thinking theoretically, let's just put some numbers to it. I make $25,000 a year. If I make $25,000, I take a 10% raise and then a 10% cut, I'm going to end up with this situation. Okay, I'm going to do $25,000 times 1 plus 0.1 times 1 minus 0.1. So there's my raise, there's my cut. If I do this in my calculator, I'm going to get $24,750. Okay. Now, if I do it the other way, I'm going to have $25,000, 1 minus 0.10 for my cut, and then 1 plus 0.10 for the raise. Sure enough, I'm going to get $24,750. These are actually the same, and I just told you on the other slide that they're not always the same. The reason that these are the same is because we're talking about the same number here, and we're talking about doing them simultaneously, not adding. We're not doing 20% at any time, and we're not minus 10 and plus 10, changing it not at all, right? Either way, we're less than what we started with. Either way, we're at 24,755 when really we started at 25,000. If you know about math from a previous class where we have the commutative property, we can do these 3 factors in any order that we want. So here, it doesn't matter what order we do them in. We've done them in 2 separate orders here, and we've gotten the same answer. The only way that one gets above $25,000 is if our raise is bigger than our cut. Okay? So always, it's good to check intuitively, but it's also good not to always just trust your gut. Put some real numbers with it, see what happens. Okay, so if you have any questions, where are you going to look? Well, if you have questions, you're going to look in your text, right? There's lots of problems worked out through your text. In the actual text section by itself. And then in the practice problems, remember there are solutions to all the practice problems in your text. You can look at the other supplemental lecture notes. Remember, they have videos embedded also. Remember that the Math Center is available to you for free. And also remember, I'm here, okay? I have virtual office hours to help you, and many times you don't even need to do an office hour Zoom, okay? Feel free. If you think that it's something that I can just explain to you by email, send me an email. Sometimes I can sketch something out and show you. Sometimes I can just explain it in words. And that way, it's really convenient for you at any time. Send me an email. I'll get back to you when I can. If you'd like to meet on Zoom, remember I have my office hours, and I also have, by appointment if you need further than that. Please practice, practice, practice. Okay, we have a test coming up. The end of Unit 1 is coming up, so you're definitely going to get practice. Again, some of this should be review, but some of it is definitely not review for a lot of my students. And so get that practice. Be ready to ace your first test. Thanks for tuning in, and I will see you next time.